Hello friends, up till now we have covered gamma function and we have introduced a beta function. In gamma function, one beautiful thing is that as per definition of this gamma function, 0 to infinity e raised to the power minus x raised to the power n minus 1 into dx and all this beta function. One beautiful thing is that if we have suppose 7 number, then we can write this 7 number n plus 1 form and we will get this as n factorial as a number. And in this case, we are getting a 6 factorial and we will find out value of 6 factorial. Or this function we can write in this definition. Since the gamma 7 is nothing but integration 0 to infinity e raised to the power minus x into x raised to the power 6 into x. And answer for this we are getting is factor. Means if I have this integration e raised to power minus 2, sorry, minus e raised to power minus x into x square into dx, directly we are getting this answer of this is a gamma 3. And gamma 3 is nothing but 2 factor. Answer is 2. This is the beautiful thing. And directly we are getting answer for this type of improper. This enjoyment is not there till I'm saying till what we have discussed in beta function. Beta mn is nothing but integration of x raised to power m minus 1 into 1 minus x raised to power n minus 1 into x. Convert this for n greater than 0 and n is 0. This is as per definition. Again, we are getting some beautiful result from this. The mn is equal to nm satisfying symmetric property. Then beta mn is equal to 2 into integration 0 to infinity sin raised to power 2m minus 1 theta cos raised to power 2n minus 1 theta into theta, or same result you can write for this integration 0 to infinity sin raised to power p theta into cos raised to power q theta into d theta is equal to 2 into theta of p plus 1 by 2. But suppose I have this integration. I will write this integration 0 to infinity x square into 1 minus x cube into dx 0 to 1. Yes, this is the integration we can write as per our definition of beta function raised to power m minus 1 into 1 minus x raised to power n minus 1. Here m minus 1 equal to 2 and n minus 1 equal to 3. From this we are getting m equal to 3 and n equal to 4. Therefore, this integration we are getting this as beta of 3, 4. Even though if we are getting this beta of 3, 4, just x square into 1 minus x cube into dx is a beta of 3, 4. Further meaning of this state we are not knowing. Only beta of 3, 4 is there. Okay. What we are building, what we are doing, what we are understanding from this. Only up till now we are knowing meaning of this. Answer for this integration is a beta 3. But we are not getting that sense, just like in the gamma function. In gamma function, directly this integration is there and we are getting answer at 6 factorial number. We are here also we are getting this number. But that sense we are not getting from this beta function. Therefore, we have to build a new thing about this beta function. Therefore, I will give one story, and by using this story, we'll try to find out is there is there any relation in beta function beta n and gamma function or gamma n? Is there any relation in this beta function and we try to find? If we are getting relation, then we can find integration. But one thing is remember that gamma function you can write in factorial form. This is a positive. In the same way, we'll try to build something about this. Now I will write here. We know the definition for this beta mn is equal to, we're getting this definition as integration 0 to infinity x power m minus 1. You can write n minus 1 also. So we are knowing that beta mn is m minus into 1 minus x raised to power n minus 1 into t. Now I will write this integration 0 to infinity 1 minus x raised to power n minus 1 into x raised to power m minus 1 into t. Okay, then I will suppose this is my first function and this is my second function, and applying integration and applying integration by parts. I think this is my first function and this term is my second function. But try to remember that here this function is again polynomial. Third polynomial x and 1 minus x. This is a polynomial and this is a polynomial. The degree is n minus 1. Therefore, it is clear that its n minus 1th derivative means I will write d by dx of x raised to power n minus 1 is n minus 1 factorial here. And after this derivative means nth derivative becomes 0. Its n minus 1th derivative is constant, means we have to integrate up to n minus 1th term. Sorry, here I have to write like this is 1. Right. This is 1. Then I will try to integrate up to n minus 1th derivative. Now I will write, we are knowing by parts, this is equal to 1 minus x raised to power n minus 1 first term x. Integration of this second term m divided by m between limits 1 minus integration 0 to 1 derivative of this term n minus 1 into x raised to power n minus 2 into x raised to power m divided by m into x. I hope you are getting it. That means 1 minus x raised to power n minus 2 into, we have to take derivative of first term, the integration of second term, but if we are taking derivative minus a derivative of 1 minus x is a minus. Now if we are putting upper limit, see here, this upper limit if we are putting here, then this term becomes 0, 1 minus 1. And if we are putting lower limit for this x, this becomes 0, means upper and lower limit becomes 0. Therefore, this total term becomes 0. Now, minus minus becomes plus sign. Here, this minus and minus becomes plus sign. N minus 1 and this m both are constant. I am taking outside. N minus 1 divided by m into integration 0 to 1 minus x raised to power n minus 2 into x raised to power m into dx. Isn't it? This is our first, when we are applying integration, first integration by parts, and we are, I will find out second integration. It's your first integration, we are getting n minus 1 divided by m. Again, I will apply. Again, applying by parts, get, we will write by parts, and then we get this term as, again here, again applying by parts, get this term. First term I'm keeping it 1 minus x raised to power n minus 2. This is my first term into integration of second term here. This is my first term. This is my second term. Taking first term as it is. Integration of second term is m plus 1 divided by m plus 1 minus, so let this term here, minus integration 0 to 1, derivative of first term is n minus 2 x raised to power n minus 3, same term as it is, n minus x raised to power n minus 3, and here derivative is minus, into x raised to power m plus 1 divided by m plus 1 into. Again, if we are applying limits here 0 to 1, then what's happening here? Again, when I will put upper limit and lower limit, this total term becomes 0. When I am putting upper and lower limit, this total term becomes 0. Therefore, only remaining term is, so here this is minus sign, here is minus, here is minus, total becomes minus plus. Therefore, this integration I will write directly. This becomes here n minus 1 divided by m. Second term n minus 2 divided by m plus 1 into integration 0 to 1 x 1 minus x raised to power 1 minus x raised to power n minus 3 into x raised to power m plus 1. This is after when we are applying second type by parts. If we are applying second type by parts, we are getting this. Now we are continuing this process. How many times? Up to, we are continuing this process up to this derivative, because we are knowing that n minus 1/3 derivative is constant. After that, derivative becomes 0, and after that, remaining term becoming 0. That's why we have to take successively this by part. We have to apply up to n minus 1. Then what will be your generalization? I'm continuing this process. Continuing this process, what you will get means here we have to apply derivative for first time. We have to apply derivative n minus 1/3 time. Then what is happening here? This we are getting n minus 1, n minus 2, and so on. We are getting 2 into 1, and here denominator we are getting m into m plus 1, and so on. We are getting m plus n minus 2 times. Remaining term, this derivative becomes 0, and remaining term is 0 to 1, x raised to power m plus n minus 2 into dx. Only this term, because remaining term becomes 0, and here this is minus. From this, we'll get this term as, can I write here this term? This is 1 to n minus 2, n minus 1, 2, 1 minus 2. Therefore, n minus 1, I will write as n minus 1 factorial divided by m, m plus 1, and so on, m plus n minus 2. Its integration is m plus n minus 1 divided by m plus n minus 1. It will limit 0. Therefore, we are getting this term as n minus 1 factorial whole divided by m into m plus 1. So on, this is m plus n minus 2, and remaining term is m plus n minus 1 only, because upper limit is there, lower limit is 0. This is your beta mn. That means we are getting now beta mn in terms of some number form. I will again rewrite this term, n minus 1 factorial whole divided by this m into m plus n, m plus 1, m plus 1, and so on to m plus n minus 1. I will multiply and divide by this term, m minus 1, m minus 2, and so on up to 2 into 1, whole divided by m minus 1, m minus 2, and so on. I'm multiplying divided by m minus 1 factorial. This is numerator term n minus 1 factorial. This term becomes m minus 1 factorial whole divided by. Now see how terms are here running. Now I'm writing this term. First I will write this term, then here this first, then second, up to m, and after this m, m minus 1, m minus 2, and so on. Means I'm changing order of this, reverse order. This is m plus n minus 1, m plus n minus 2, so on up to m, यहाँ तक आ गया, up to m. Then m minus 1, m minus 1, m minus 2, 2. That means this total term denominator is nothing but n minus 1 factorial, this is numerator, and denominator is m plus n minus 1 factorial. Okay, m plus n minus 1 factorial. Oh, very nice. We are getting beta of mn is equal to this. But we are knowing here in terms of gamma function. I will talk here, this is about only gamma of n. What is gamma of n? This is in terms of factorial, or gamma of n plus 1. Gamma of n plus 1 gamma of n plus 1 is equal to n factorial. Therefore, gamma of n minus 1 is equal to right here. The gamma of n, only gamma of n. Gamma of n is equal to n minus 1 factorial. Similar way, gamma of m plus n is nothing but m plus n minus 1 factor. Similar way, we are getting this as gamma of n because gamma of n minus 1 factorial. This n minus 1 factorial is gamma of m. Similarly, we are getting gamma of m plus n minus 1. M plus 1 minus 1 factorial is m plus m plus. Means we are getting this. What is beta mn is equal to gamma m into gamma n divided by gamma m plus n. So for m and n, okay. Now we are getting a beautiful result. This beta mn is equal to gamma n or gamma n doesn't n divided by m plus. Okay. Means here this is nothing but relation between beta and gamma. Relation between beta and gamma. So this relation helps to find out integration. Now I will take care of it. Find value of integration 0 to 1 x raised to power 4 1 minus x raised to power 3. I will find this value. We are doing this integration 0 to 1 x raised to power m minus 1 into 1 minus x raised to power n minus 1 into dx. This is a beta mn is equal to, here we are getting m minus 1 is equal to 4, n minus 1 equal to 3. This m is 5 now, n is 4. Therefore, this is nothing but beta of 5. Okay. Now beta of 5 4. I will use now this formula. Beta of 5 4 is equal to, it use now this formula. Beta of mn is equal to gamma m gamma n divided by gamma m plus. By using this formula, I will write this is gamma 5 gamma 4 divided by gamma 4 or 5 plus. What is gamma 4? Gamma 4 is 4 factorial. Sorry, gamma 5 is 4 factorial. Gamma 4 is 3 factorial. And this is a 9. Gamma 5, gamma 4, divided by gamma 9. Gamma 9 means 8 factorial. This is 8 factorial. 3 factorial, 7 factorial divided by 8 factorial. Now this is a 4 factorial. 3 factorial means 3 into 2 into 1 whole divided by 8 factorial. It's 8 into 7 into 6 into 5 into 4 factorial. 4 factorial, 4 cancel. Here this is 3 and here is 2. This 4. Here we have 4. This is nothing but 1 divided by 7 into 4 into 5 into 2. 1 divided by 8. Integrate. Now we are getting answer. And why we are getting answer for this integration? Because we have a strong relation beta mn is equal to gamma n m divided by gamma m plus. This relation you can find now. Solve this integration of beta function to convert into gamma function and we get direct. Here simple integration 0 to 1 x raised to power 1 by 2 into 1 minus x raised to power t. I will find what is m minus 1 here. N minus 1. N minus 1 doesn't matter now because we are knowing that both is metric. M minus 1 is equal to 2 and n minus 1 equal to 3. Therefore, m equal to 3 by 2 and n equal to 4. Therefore, this given function is nothing but beta 3, 4 means here integration 0 to 1 x raised to power 2 into 1 minus x raised to power 3 into d is nothing but beta 3 by 2. How we find beta 3 by 2 come up? This is just like a beta mn. This is a gamma 3 by 2 into gamma 4 divided by gamma 3 by 2 plus 4. How will solve this? This is a gamma 3 by 2 into gamma 4 divided by gamma 300. Now we try to find out this. Where to find out value answer for this? To simplify this, first I will do you which problem we have already solved. Gamma of 3 by 2. Gamma of 3 by 2. You know this formula. Gamma of n plus 1 is equal to n into gamma n. Now n is not an integer. This is just like I will make 1 by 2 plus 1. And this is 1 by 2 into gamma 1 by 2. And we are knowing gamma 1 by 2 is the root. Therefore, 3 by gamma 3 by 2 is we are getting 1 divided by root. Then again gamma 11 by 2. Gamma 11 by 2. In similar way, I will use this formula and we are getting here. You can reduce by 1. 9 by 2. We are getting gamma 9 by 2. No, gamma 9 by 2. Here we are getting gamma 9 by 2. So gamma 9 by 2 this term. Gamma 9 by 2. Here 9 by 2 I am keeping as it is. What is gamma 9 by 2? This gamma 9 by 2 is 7 by 2 into gamma 7. I will write here that 5 by 2 into 3 by 2 1 by 2 into gamma 1 by 2. This is equal to 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into gamma 1 by 2. Okay, this value is there. And gamma 4, we are knowing gamma 4, the 4 is integer. Gamma 4 is 3 factorial. Then how will write this answer? Therefore, this is a beta 3 by 2 comma 4 is equal to, we are getting this answer, gamma 3 by 2, 1 by 2 into root pi into 3 factorial whole divided by 9 by 2, 7 by 2, 5 by 2 into 3 by 2, 3 by 2 into root. Solving this, simplify this, and not simplify, you will get this. Okay. And this is the beauty of this beta function as well as gamma function. And beta function, we can solve problems when we are knowing formula or relation between gamma and beta function. Thank you for this video, and in next video we'll solve problems based on some problems based on this formula. I will recall that. Here also I will recall this formula. G pi by 2 pi raised to power p theta into d p theta or px p theta into cos of q theta cos of theta into d theta is equal to 1 by 2 into beta of t plus 1 t plus. Okay, we solve some problems on this integral formula, which is in terms of theta and gamma function. And thank you.